Good day, welcome to Wamlad Academy. Today we want to look into 4 important terms using in chemistry. The first one we have element, atom, molecules, and compound. So what do you mean by element? Element is the chemical substances that cannot be split into 2 or more simpler forms by any ordinary chemical reaction. And when we are talking about these elements, of present, we are known about 118 elements. That means we have 118 elements. And out of this 118 elements, 92 out of them they are what? They are naturally occur. 92 are naturally occur. So whereby the rest are what? Are synthetic. That means 118 minus 92, that will be what? That will be 26. That means 26 are synthetic. We can just say are man-made. So that's the number of elements we have. We have 118 elements, 92 are naturally occur, while 26 are man-made. And if you are discussing about these elements, if you don't forget when we are talking about the matter, we said that matter, it has the classes and it has state. Among the class of matter, that's where you have element, compound, and mixture. And when I talk about the state of matter, we have gas, liquid, and solid. And at room temperature, all these 118 elements, there are some of them that exist as solid, while some of them exist as liquid, while some of them exist as gaseous. So out of this 118 elements, it's only 2 elements that exist as liquid at room temperature, which are we have got bromine and mercury. These 2 elements, they are what? They are liquid at room temperature. So, and among these 118 elements, we have 11 elements that exist as gaseous. So these 11 elements that exist as gaseous, the first one there is hydrogen, we have nitrogen, we have oxygen, we have fluorine, we have chlorine. You see have all the 6 noble gases where you have our helium, we have neon, we have argon, we have xenon, we have krypton, and we have our radon. So all these 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all these 11 elements, they exist as what? As gaseous, as gas. So the remaining ones, that means 2 plus 11, that is 13. 118 minus 13, that means the remaining one, 118 minus 13, we are going to have what they call 105. That means the remaining 105, they exist as what? As solid. So, and when I talk about this element into 2, element they are divided into 2, whereby we have what we call metal and we have what we call non-metal. And in some cases, whereby we see as one, the other one that we call it metalloid. This metalloid has the both characteristics of metal and what are non-metals. So that's about the elements. We have metal, we have metalloid, and we have non-metal. But if you check what I did here, you see that I say hydrogen, I represent at H. So that's what we call chemical symbol, or that's what we call chemical symbol. Hello, bro. This is disturbing. I'm doing something here. I'm not saying you should go outside. You can go on that side. So like I said, we have elements which you have metal, metalloid, and non-metal. But if you check this, you see that when I write hydrogen here, I write it as hydrogen H, nitrogen as N, and oxygen as O. So that's what we call chemical symbol. The way we are representing the name of the element, we call it what? Chemical symbol. And this chemical symbol of a thing, it was suggested by a scientist called John Pencilius. So this, according to this guy, he suggested that there are some elements, it has 3 cases. The first case is that there are some elements, they use the first letter of their name to represent their name. For example, hydrogen. This hydrogen here, the name is hydrogen. they use the first letter here, which is capital H. We use H to represent the symbol of hydrogen. And there's a one rule that anytime you are writing the chemical symbol of an element, if it only has only one letter, that letter must be in what? Must be in upper case. So the second case is that is either they use first and second letter or first and third letter, which means the symbol will have two letters. So in this second case, we have example of helium, this He. Helium is written as this helium, and the chemical symbol is what? He. They use this first letter and what? And the second letter. So we see another example, the aluminum, let's say we have magnesium. This magnesium, they use the first letter and third letter. That means the symbol is what? Is Mg. So the third cases that I will talk about is just generating their symbol from their Latin name. So for example, you have sodium, but the symbol of sodium is Na. But the question is that if you check all this sodium, the letter you have in sodium, there's something like N and A. So they get this chemical symbol from the Latin name of sodium. What's the Latin name of sodium? The Latin name of sodium is natrium. So the symbol is Na. So the same thing with iron. When I talk about iron, the chemical symbol of iron is what? Is Fe. And they generate it from the word Latin name. The Latin name of iron is what they call ferrum. Another one we have what they call silver. The chemical symbol of silver is Ag, and from the Latin name, which is what? Which is argentum. So you also have others elements like that. Especially most of them are metals. You have what you call copper. The chemical symbol of copper is what? Cu, which is from what? From copper. So that's about the element. That is a chemical symbol that cannot be seen in two or more similar form. We should know that this element, as present now, we have 118 elements, which 92 of them are occur naturally and 26 are man-made. And out of this 118 elements, we only have two elements that are what? That are liquid, which is bromine and what? And mercury at room temperature. And at the same time, you have 11 elements that are what? That are gaseous at room temperature, which are hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, xenon, krypton, radon. And the rest, they are what? They are solid, which they are 105. And these elements, they are basically classified into metal and non-metal, which you see later have something called metalloid, because it has both properties of metal and non-metals. So the name of science that suggests about the chemical symbol is just bacillus. The symbol of hydrogen is H, while the symbol of helium is Hg, and the symbol of magnesium is Mg. So that's about the element. So the second one we discuss about today is atom. What do we are this atom? Atom is smallest particle of an element which can take part in a chemical reaction. That's about the atom. So in some cases, they say that atoms is indivisible particles of an element. They can take part in a chemical reaction. So in these atoms, you have what they call neutral atoms. We have to call neutral atom and we have what they call ion. What is neutral atom is that when we have an atom without any charges, even when it does not carry any charges, we call it neutral atom. But when it carry charges, maybe it carry positive charge or negative charge, we call it ion. And this ion also divided into two. That's why we have what we call cation and we have what we call anion. It says that any atom that we see that it carry charges, maybe it carry plus, like Na plus, Ca2 plus. So all these, they are what? They are cation and they are ion. For anion, when you have O2 minus, you have F minus. You can see that all these atoms, they carry charges, plus, minus, all they are called what? They are called ion. And there are some cases whereby we have what we call radical. What do you mean by this radical? Radical. So this radical, they also carry charges, maybe positive or negative charges. Radical are two or more elements that behave like a single entity. I can put it in this way that radical are two or more atoms that behave like a single entity. For example, now, if you have OH minus, you can say that in this case, you have two elements here, oxygen and hydrogen. So, can they carry charges? Can I say this one is ion? No, this one is what they call radical. Because you have two elements here. If you have only one element, that's when you have what you call ions. And we see how what's called about atomicity in this case of atom. What do you mean by atomicity? Atomicity is the number of atoms in the molecule of an element. There are some elements that are monoatomic, while some they are atomic, while some they are what? Polyatomic. What do you mean by monoatomic? Monoatomic, monoatomic that means they can start alone, like sodium, yeah, magnesium. All these they are what? They are monoatomic. We are not talking about diatomic. So all the same elements they are atomic, like chlorine gas, oxygen gas. This one is the oxygen element. Oxygen gas, you have hydrogen gas. So you see them anytime they want to write this, they put two there because they are what? They are atomic. And see how they call polyatomic. So polyatomic like case of phosphorus where you have P4, like case of sulfur where you have S8. All these are what? Polyatomic, and that's about the atomicity. So when I talk about the molecules, molecule is the smallest unit of a substance that retain its chemical properties, consisting of two or more atoms held together by what? By chemical bond. So example of molecules is where you have examples are we have oxygen molecule, you have hydrogen molecules, you have one molecule of HCl, you have one molecule of H2SO4. So it does not mean that when I talk about molecule, it must be the element or it must be the same atom. No, you can have different atoms that form a molecules. So this one is a molecule, this one is molecule. Here you can say this one is what? One molecule of oxygen gas, one molecule of hydrogen gas, one molecule of HCl. For example, I have something like this. If I say 2N2, this one is saying that I have two molecules of nitrogen gas. So but how does molecules and atom related? For example now, if you check this in case now, you have two molecules of nitrogen gas, but how many atoms do you have there? You have four atoms of nitrogen. You have four atoms and two molecules, because it's two atoms that make up of this one. Two times we are going to have four. That's why you have four atoms. For example, you have oxygen gas like this. In this case, we have how many atoms? So we have two atoms of oxygen, two atoms of oxygen, whereby we have one molecules. Let's check this one. Let's say we have two HCl. In this case now, you have two HCl. Here we have how many elements? You have two elements. The two elements you have here is what? Is hydrogen and what? And chlorine. But how many atoms do you have here? You have four atoms, because you have two atoms of hydrogen and two atoms of chlorine, making what? Making four atoms. It means that when you have a compound, the number of elements there and the number of atoms may not be the same thing. So but there are some cases whereby they be the same. Let's say we have HCl. In this case HCl, the number of atoms is two while the number of elements is two. But when you have two molecules of HCl, it shows that the number of atoms here is four while the number of molecules is what? Is two. Let's take another example. Let's say you have H2SO4. In this case now, H2SO4, how many number of atoms do you have here? How many elements and how many molecules? The element you have here is what? Elements you have in this case, we have hydrogen, we have sulfur, we have oxygen. That means the element you have what? Is 3. What about number of atoms? The number of atoms you have here, you have two atoms of hydrogen atoms. You have two atoms of hydrogen plus one atom of sulfur plus four atoms of oxygen plus 4. So which means you have 7 atoms. But how many molecules? You have only one molecules. I believe you understand it. So if you understand it, then now move to what they call compound. So the last one we discuss today is compound. What do you mean by compound? Compound is made up of two or more different atoms chemically combined together. There's a one key word there. They say different atoms. That means for you to have what you call compound, that atom that made up of that substances must be what? Must be different. For example, you have NaCl. This NaCl is a what? Is a compound because it's made up of two different atoms, sodium and what? And chlorine. Then you have oxygen gas. This one is not a compound. It's not compound because it's made up of the same atom. But let's say you have a case of HCl is a compound. If you have HNO3, this one is a compound because they made up of two or more different atoms. So what is now the relationship between compounds and molecules? There's a rule which say that all compounds are molecules, but not all molecules are compounds. What do I mean? All compounds are molecule, but not all molecules are compound. So what do you mean by this rules? That all compounds are molecule, but not all molecules are compound. For example, now when you have NaCl here, this NaCl is a compound, and at the same time also what is also a molecule. But let's say you have oxygen gas. This oxygen gas is not a compound, but is a what? Is a molecule. Can you see that all compounds are molecules, but not all molecules are compound? So that's all about the element atom molecules are compound. And there's one fifth one like this, we call it mixture. They said mixtures, the difference between mixtures and compound is that one is physically combined together, while this one is what? Is chemically combined together. And there's another thing I want to let you guys know here. When you have something like this, CO, and you have something like this, CO. If you check this one now, this one is the same differentiation between these two. This one is element, while this one is what? Is a compound or is a molecule, because all compound are molecule. Why this one is element and this one is compound? If you don't forget, I said there's something called chemical symbols, which suggested by John Benson's. So according to that rule, he said that when two letters are representing the chemical symbols of an element, the first one will be in uppercase, while the second one will be in lowercase. So if they are in uppercase, it means that it's not more elements. But if one is uppercase and another one is lowercase, it's known as what? It's known as element. So if you understand this, so let's do this simple exercise together. They say in tabular form, classify the following into atoms, molecules, compounds, and ions. You have F2, CH2OH, S2 minus, NH4 plus, Al3 plus, N2, NO3. If you understand what you did, definitely you must be able to answer this question. Let's do our table solution. You have the set into atoms, you have molecules, you have compound, and you have ions. Let's check the first one. You have F2. Is this an atoms or molecules or compounds or ions? If you check it very well, this one is not atoms. It's what you call molecules. That means F2 is what? Is molecules. Is it a compound? No, because all molecules are not compound. Is it ions? No, because it does not carry any charges. The second one, we have CH3, CH2OH. This one from here, you can see that it's not an atoms, it's not an ion because it does not carry any charges. But it's a what? It's a compound. We have CH3, CH2OH. But don't forget that we said all compounds are what? Are molecules, which means you can still write here that CH3, CH2OH. And if you take this compound like this, how many elements do you have there? You have 3 elements: carbon, hydrogen, and oxygen. Now when they ask us to calculate the number of atoms there, you have 1, 2 carbon, 3, 2, 1, 6 hydrogen, making 8. You have 1 oxygen. That means you have 9 atoms in this compound. So the next one, yeah, S2 minus. This one is what is ion because it carry negative charge and it also belongs to what they call cation. Let's say this one NH4 plus. Actually, if you check this NH4 plus is a radical, but so far they not include radical here. That means is we can put it in what ion NH4 plus. But in the case whereby they still put radical, that means this NH4 plus will go to what to radical. And we have Al3 plus. This Al3 plus at the same time is also what is also ion, which is what is cation because it carry positive charge. And N2 is what? This our N2 is a molecule. What about Na3? Na is also a what? It's also a molecules. And at the same time, it's also what? It's also a compound because it consists of two different atoms, which is nitrogen and hydrogen. So which means from this, there's no any atom there. But let's say in the case whereby they put F, they put oxygen, they put Al like this. So F, Al, they be what? Under atoms. And there's one thing you need to correct as from today. When they ask mention that which gas are you breathing, they say oxygen. So you cannot just say oxygen. Oxygen is not correct. What you need to say is that oxygen molecules, because if you say oxygen, you are referring to atom. So I believe you learn one or two things from today's class. Don't forget to hit the subscription button, like this video and comment. But before you go, I also have a small task for you. Check this question, do it and drop your answer in the comment section. See you in our next class.